if angle theta is in standard position, then the reference angle for angle theta is the smallest angle between the terminal side of theta and the and the x-axis. Let's take a look. Here we have 120 degrees. We want to draw it in standard position and then name the reference angle. So if I go around my coordinate system, if my angle in standard position terminated here, that would be 0 degrees. If it terminated straight up here, that would be 90 degrees. Over here, 180 degrees. And down here, 270 degrees. If I went all the way around and made it back to here, that would be 360 degrees. So the angle I'm talking about is 120 degrees. That's between 90 and 180. So I'm going to draw it in right here. Here is 120 degrees. That's my angle theta. The reference angle for angle theta is the smallest angle between the terminal side of theta and the x-axis. I think I said the positive x-axis before. That's not quite right. It's the x-axis period. So here, to go from 120 to 180, that's going to be 180 minus 120, which is 60 degrees. So the reference angle for angle theta, I'm going to say is theta with a little hat on it, is 60 degrees. So when 120 degrees is in standard position, then its reference angle is 60 degrees, and that represents the smallest angle between the terminal side of theta and the x-axis. Here's our next problem. Find the exact value of cosine 225 degrees. So again, I'm going to go around my coordinate system here. This is 0 degrees, 90 degrees, 180 degrees, 270 degrees, and then back to here would be 360 degrees. So 225 degrees is between 180 and 270. So I'm going to draw it in right here. Here's my angle, 225 degrees. And then its reference angle is, right here, 45 degrees. That's 225 degrees minus 180 degrees is 45 degrees. So the cosine of 225 degrees is going to be equal to, now, I know that my angle terminates here in quadrant 3. In quadrant 3, my cosine function is negative. So I'm going to put a negative sign in here, and that's because of quadrant 3. And then I know that the numerical value for cosine 225 will be the same as the numerical value for the cosine of its reference angle, 45 degrees. So I have the cosine of 225 is equal to the opposite of the cosine of 45. Cosine of 45 I've memorized. It's 1 over square root 2. So drawing this little diagram right here kind of helps us visualize where our angle terminates. Then we find the reference angle. The numerical value of the trigonometric function of an angle and its reference angle will differ at most in sign. So here I know cosine 225 will be the opposite of the cosine of 45. I've memorized cosine 45, that's 1 over square root 2, so my answer is just negative 1 over square root 2. My next problem, find theta if sine theta is negative 0.3090 and theta terminates in quadrant number 3. So I'm going to work on a calculator here, and I'm going to say, okay, sine theta is equal to negative 0.3090. Now I'm going to enter just this on my calculator, press my inverse sine button, and I'll end up with my reference angle. So if I just put the numerical part in without regard to the sine and press my inverse sine button for 0.3090, I'll end up with my reference angle, which in this case comes out to be 18 degrees. So that's what my calculator gives me. Now I know that theta terminates in quadrant 3. Its reference angle is 18 degrees. Remember, this is 0, that's 90, and they're degrees, 180 degrees, and 270 degrees. So I'm in quadrant 3 with a reference angle of 18. I'll draw this in. This is 18 degrees. So my whole angle theta right here must be 180 degrees plus 18 degrees, which will be 198 degrees. So angle theta comes out to be 190 degrees, and I found it by knowing that sine theta is negative 0.3090 and theta terminates in quadrant 3. If you just input negative 0.3090 on your calculator, press your inverse sine button, you won't get the correct answer. you'll end up with negative 18 degrees for the answer because of the restrictions on my inverse sine button in the calculator. So we have to do it this way. Here's one more problem. Find theta if sine theta is negative square root 3 over 2 and theta terminates in quadrant 3. So again, here's 0 degrees, 90 degrees, 180 degrees, 270 degrees. Sine theta is equal to negative square root 3 over 2. My square root 3 over 2, along with the sine function, tells me that my reference angle is going to be 60 degrees, because the sine of 60 degrees has an exact value of square root 3 over 2. So here's my reference angle. I want to be in quadrant 3 with a reference angle of 60, so I'll draw that in. This tells me that theta itself must be 180 degrees plus 60 degrees, and that will come out to be 240 degrees. So same kind of problem as problem number 3, except I'm using exact values here, and I know that I've memorized the fact that the sine of 60 degrees is square root 3 over 2. So I forget the algebraic sign to begin with and just let this numerical value here give me my reference angle. Then from that in my little diagram, I can find the actual angle itself.